All right, we're starting out with the practice AP style questions. So we're looking at rate of change patterns for linear functions versus quadratic. So the first thing to do is fill out the table. And sometimes we refer to this as first differences. But I like using first average rate of change better because it's not always true that they'll give us a table where the x increases by 1. So if I'm finding rate of change, what I'm doing is finding the slope between these 2 points. Remember, this is x and this is y. So you would do 2 minus negative 1 over negative 1 minus negative 2. That's 3 over 1. So the first average rate of change is 3. And then you do that for each one. So 5 minus 2 over 0 minus negative 1. That's also 3. And 8 minus 5 over 1 minus 0. Now, if you can do this in your head, that's fine. I am getting 3 every single time. 11 minus 8 over 2 minus 1. So the first average rate of change is constant. And then the second average rate of change, so that would just be what's the rate of change of the rate of change. So use these as the y values and still use the x values. So it would be like 3 minus 3 over 0 minus negative 1. 3 minus 3 over 1 minus 0. Again, you don't have to show the work. I'm just showing how I'm getting these values. 3 minus 3 over 2 minus 1. So that's change in the first average rate of change divided by the x values, the change in x values. So the second average rate of change is 0. So is f of x linear or quadratic, and how can you tell? The rule is if the first average rate of change is constant, that means that you have this constant slope, right? Remember, average rate of change is slope. So if the slope is constant, I have a linear function. So f of x is linear because the first average rate of change, you can say AROC on your AP exam, is constant. Basically, these y values are going up 3 units for every one unit change in x. Are the rates of change for f of x increasing, decreasing, or remaining constant? All right, so are the rates of change increasing, decreasing, constant? Remember, we listed out the rates of change. The first AROC is always 3. So rates of change are constant. Remember, rate of change is just asking about slope. And if f of x is linear, the slope is constant the whole time. Not meaning flat line, meaning the slope doesn't change. Is f of x concave up, concave down, or neither? A linear function that looks like this has no concavity. So because f of x is linear, there's no concavity. Remember, concavity goes with rate of change increasing or decreasing. So if it's remaining constant, there is no concavity. Okay, so let's do this again. Again, I'm noting that the x values are just changing by 1. So when I find the first average rate of change, it should always be divided by 1. So 4 minus negative 1, so plus 1, over negative 2 minus negative 3. 5 over 1 is 5. 7 minus 4 over negative 1 minus negative 2, so plus 2. So that's 3 over 1. 8 minus 7 over 0 minus negative 1, that's 1. And 7 minus 8 over 1 minus 0 is negative 1. So the average rate of change is definitely changing. And then how do I find the second average rate of change? So use the first average rate of change as your new change in y. So 3 minus 5 over negative 1 minus negative 2. So the second average rate of change is negative 2. We dropped 2. That's what we're saying. And I can kind of see that's happening again, minus 2. But if you want to do the work, 1 minus 3 over 0 minus negative 1. is also negative 2. Same thing with this one, negative 1 minus 1 over 1 minus 0, negative 2. All right, so this time, because the first average rate of change is changing, if you were to sketch those out, you have a slope of like 5 and then 3 and then 1 and then negative 1. That's definitely not a linear function. This is quadratic. F of x is quadratic. How can you tell using the first or second differences? So it's not just that the first differences are changing, it's the amount they're changing by. The second average rate of change is constant. So that means that we have a quadratic. So f of x is quadratic because the second AROC is constant. Are the rates of change increasing, decreasing, or remaining constant? So you can see that the first AROC are decreasing. And you can also see that because the second AROC is consistently negative. I'm going to say is always negative 2. If the second average rate of change is negative, it means the first average rate of change is decreasing by that same amount. Is f of x concave up, concave down, or neither? So f of x is concave down. Now I sketched a little bit. You can sketch the slopes here. Or remember, we have a rule, concave down because first average rate of change is decreasing. Right? Or you could say second AROC is consistently negative, either way. All right, this one needs a calculator, so use a calculator for this question and round the answer to the nearest thousandth. That's 3 decimal places. The electromagnetic force between two particular particles is related to the distance between the particles. This relationship is modeled by the function f. So, sorry, this is blurry, but it says f of d is 3.6 over d squared. D is measured in centimeters, force is measured in newtons. What is the average rate of change in newtons per centimeter in the electromagnetic force if the distance between two particles is increased from 2.3 centimeters to 3.1 centimeters? So those are both values for D. Average rate of change is F of, I'm going to go 3.1 minus, this is average rate of change formula. F of one value minus F of the other value. And then subtract, this is change in Y, and then subtract the X's in the same order. Okay, so yeah, we're going to use our calculator for this. So this was 3.6 divided by, we're plugging in 3.1. So 3.1 squared. So that's that first number. Don't round it though. Actually, let's do this in the fraction. Let's just set it all up. Okay, so 3.6 divided by 3.1 squared. And then minus 3.6 divided by 2.3 squared. And we're supposed to divide that by 3.1. Sorry, I must put in 3.6 minus 2.3. If you use this fraction key, that was alpha y equals, it makes things so much nicer. So round this answer to 3 places, negative 0.382. So about equal to negative 0.382. We need to label this, and they told us it's going to be in newtons per centimeter. So newtons per centimeter. All right, in addition to choosing the correct answer, could g of x be quadratic? And let's explain. Okay, so for the polynomial function g, the rate of change of g is increasing to the left of 2 and decreasing to the right of 2. So the rate of change is increasing means g of x is concave up to the left of 2 and decreasing, so concave down to the right of 2. Which of the following must be true? So g of x has a minimum at x equals 2. So does that have to be a minimum? So let me just sketch this. Here's x equals 2. It doesn't say anything about increasing or decreasing, just concave up. So I could draw it like concave up till we get to 2, and then concave, and then concave down, something weird like this. That's definitely not a minimum, that's a maximum. But I don't have to draw it that way. I could say, here's 2, here's concave up, and then I switch to concave down like this. So I could make a minimum, right? Something ugly like that. So it doesn't have to be a minimum. It doesn't have to be a maximum just to have the correct concavity. The graph of G has a point of inflection at 2. Concavity changed for sure. And is concave down to the left? No, that's wrong. And concave up to the right? Nope, it's the other way. D has a point of inflection at 2 because concavity changed. Concave up on the left, concave down on the right. Yep, that's got to be D. I always try to think of counterexamples to whatever the choices are, and that usually involves a sketch. Oh, and could G of x be quadratic? Is it possible for a quadratic to switch from concave up to concave down? I don't think so. Quadratics look like this or like this. They're either always concave up or always concave down. So could this be quadratic? So let me answer this in blue here. So no, because quadratics are always concave up or concave down. All right, number 5, there's a hint here. Use the tables on the front page to help make a decision. So, oh my gosh, again, this is so blurry. I don't know what happened. The function f is defined for all real values of x. For a constant a, the average rate of change from x equals a to a plus 1 is given by the expression 2a plus 1. Which of the following statements is true? Okay, so there's this little table where we put in x's and f of x's. And when we put in a to a plus 1, I don't know these function values, but the first a rock, so f of a plus 1 minus f of a over a plus 1 minus a, that came out to 2a plus 1. Okay, so the choices are, is the average rate of change over consecutive equal length input value intervals, it's positive, so the graph could be aligned with a positive slope. Let's see. Now a can be anything. If a is like -4, then that doesn't work, because then the average rate of change is something negative, so that doesn't have to be true. The average rate of change is positive. Again, that is positive thing, rules that out. The average rate of change of f over consecutive equal length input intervals, so just average rate of change between two consecutive numbers, is increasing at a constant rate. So the graph of f could be a line with a positive slope. Now that doesn't sound right because average rate of change needs to be constant to be a line. So I don't think that's it. So let's see if D's make sense. The average rate of change of f over consecutive equal length input intervals is increasing at a constant rate. So the graph could be a parabola that opens up. Now, see, this doesn't say that a is positive, so I feel like I could argue that 2a plus 1 is not strictly increasing if a is negative. But I think that this has to work because 2a plus 1 could be an increasing function. Like that's a line that has a slope of that, right? Oh, you know what? And even if a is negative, as we increase a, that 2a plus 1 is going to increase. So yeah, I think that's okay. So because we have a constantly increasing average rate of change, it means that the second average rate of change will be some positive number. That'll be constant. And that will make a concave up parabola. Yep, I think that's true. My hint for number 5 was like, yeah, we used like number 2. We kind of looked at this of like, oh, the average rate of change was a constant number. This one would have been a parabola opening down. If that constant number is positive, then yeah, then you would get a parabola that opens up. Okay, let's look at the next problem. So number 6, the average rate of change of the quadratic function p is -4 on this interval and -1 on this interval. What is the average rate of change of p from 6 to 8? So let's see. We have information from 0 to 2, right? We know from 0 to 2, there's this decrease of -4. And then we know from 2 to 4, there's this decrease of like just -1. But what do we know about 6 to 8? I don't think we have enough information for that, right? Because 6 to 8 would be like all the way out here. And we don't know anything about that. We could do 0 to 4, but I don't think we have enough information for this, especially without a function. Okay, number 7, an object is moving in a straight line from a starting point. The distance in meters from the starting point at selected times in seconds is given in the table. If the pattern is consistent, which of the following statements about rates of change, about the rate of change of the rates of change, so about the second average rate of change, which of those is true? All right, so let's find the first AROC and the second AROC. Let's start there. 9 minus 1 is 9 minus 1 over 3 minus 2. 3 minus 1, sorry. That's 8 over 2, which is 4. 21 minus 9 over 6 minus 3. 21 minus 9 is 12 over 3, which is also 4. 41 minus 21 over 11 minus 6. 20 over 5 is also 4. So the first average rate of change is constant. The second average rate of change will be 0. So the rates of change is 0. That's right. So it's not C or D. And the object is neither speeding up nor slowing down. The first average rate of change, is constant. So think of this as a speed. This thing is traveling 4 meters per second constantly. So the rate of change is 0 meters per second, and the object is neither speeding up nor slowing down. All right, so it's about the label here. Is the second average rate of change meters per second, or is it meters per second per second? If this one's meters per second, this is 0 meters per second, or per second squared. So, yep. Basically, if any of you are in physics, this thing has a constant velocity, which means it's not accelerating. Okay, last one, and then I'm going to stop the video and make a second one here. So the table shows values for the function g at the selected values of x. Which of the following claim and explanation statement best fits these data? So this is all like, is it linear or quadratic? So we need to find first AROC and second. So 13 minus 15 over 1 is -2. 7 minus 13 over 1, let me do it this way, is -6. -3 minus 7 over 1 is -10. And -17 minus -3 over 1 is -14. So the second average rate of change, -6 minus -2 is -6 minus -2 is -4. Yep, and then we go another -4 and then another -4. So this is a quadratic, so not linear. Quadratic because, let's see, the rate of change is constant. No, because the average rate of change over consecutive equal length input intervals, because the change in the average rate of change is constant. So yeah, the change in the average rate of change is the second AROC. The rate of change is the first AROC. It was the second that was constant, so that's D. I'm going to stop my video here because I'm out of time, and I'll make a second one for the ACT problems.